Ulara tu amalara jo haku mama leri go la so tilare mana go so ko mama leri go la so ha be yo be le zin ka yo.
I bet you have never heard that song before. That was corresponding song for cows, set in Peru, of all places. And so the reason why I played that song is today we're going to look at corresponding parts of congruent triangles. So today we're going to be proving parts of triangles congruent. So we're going to use CPCTC, you'll find out what that means very soon, to prove parts of triangles are congruent. Okay, so first some vocabulary. CPCTC. I know it's a mouthful. CPCTC. So my senior year, I had to go to physical therapy, and so I think of physical therapy amongst CCCs because my senior year of high school, I tore my ACL, and it was not a good thing. I was on crutches the whole time. Crutch. So that's how I kind of remember CPCTC, which means corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So I know it's kind of a mouthful, but it will make sense soon enough. So remember, we have multiple ways that we can prove triangles congruent. Side, 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 angle, side, angle, angle, side, and hypotenuse leg. They use congruent corresponding parts to prove the triangles are congruent. So like the side, and the side is congruent. Therefore, the triangles are congruent. Now what CPCTC does is it uses the corresponding triangles to prove that parts of the triangles are congruent. So it's kind of flipped. Like once we know that the triangles are congruent, then we can say that the corresponding parts are also congruent. So CPCTC is used as a reason in a proof after you have proven two triangles congruent. So let's take a look at an engineering application. We have a landmass or body of water that it's hard to find a direct measurement of. But what we can do is that we can draw lines or like kind of have like a rope that goes out in a crisscrossing fashion to figure out how long segment AB is, or how long this distance of the body of water is. So looking at this diagram, what we can do is that since AC is 10 miles long, and CE or EC is 10 miles long, those are congruent to each other. And BC as well as DC are 15 miles long, so they're congruent to each other. That's given to us. So basically we want to prove that these triangles are congruent and then use the other corresponding parts to show that AB is congruent to something else. So we have these two sides that are congruent. So we either need another side or an included angle. Remember, we can't prove that like A and E or B and D are congruent because that would be ASS, which we're not allowed in math class. But we do know that ACB is congruent to angle ECD because of vertical angles theorem. And so since we have a side angle side, we can say triangle ACB is congruent to triangle ECD by side angle side. Now that we know that the triangles are congruent, we can now say that a pair of corresponding parts is congruent. So we can say that segment AB is congruent to segment DE. See how AB is the first and third letter, and DE is the first and third letter. So those are corresponding parts. Now that since the triangles are congruent, we know that the corresponding parts are also congruent. And since they're congruent, we can say that that's by CPCTC. Therefore, since they're congruent, their measures are equal, and the length of AB would be 18 miles. Now, to the next one. This one, we are going to be using a different type of proof. It's called a flowchart proof. And basically, the perks to flowchart proofs is that it's not a rigid linear progression. You can kind of pick and choose where you put your flow. Typically, flowcharts go start at the top and go down, or start at the left and go right. Oh, I think that's wrong for you. Start at the left and go right. So here we're given that YW bisects, remember bisects means cuts in half, XZ, as well as XY is congruent to YZ. So that's given, and we need to prove that angle XYW is congruent to angle ZYW. All right? So in a flowchart proof, there are bubbles and then there's words below the bubbles. In the bubbles is where we put our statements, where we used to put what we used to put on the left side of the proof, and then just below it will be the reasons. So for example, here we have our statement YW bisects XZ, and then the reason is given. Here we have XY is congruent to YZ, our other given statement, and the reason is given. So what we can do is there's more free flow on where we can place things. So the next thing that we want to say is that we want to look at the bisector. Since YW bisects XZ, we also know that XW is congruent to ZW, and that's because of definition of bisector. A bisector cuts things in half or creates two congruent segments. Next is, so we see that the reason is the reflexive property of congruence. So what might that be? It's going to be that YW is congruent to WY. We want this because it's included in both sides of the triangle. It's included in both triangles. This side length is included in both sides of the triangle, so we want to say that they're congruent. Now, it's much easier to see why these triangles are congruent. We have a pair of congruent sides, a pair of congruent sides, and another pair of corresponding congruent sides. So we can say that triangle XYW is congruent to triangle ZYW. So the triangle on the left is congruent to the triangle on the right by side, side, side. Therefore, we can go and say that angle XYW is congruent to angle ZYW because of CPCTC. Since these triangles are congruent, their corresponding parts are also congruent. And angle XYW, it corresponds with ZYW. So once we've proved that the triangles were congruent, then we can say that their parts are also congruent. Okay, let's do a two-column proof on the back side. So we're given that NO is parallel to MP and that angle N is congruent to angle P. We need to prove that MN is parallel to OP. All right, so remember going back to Unit 4 where we have our parallel lines and transversal theorems. So here we know that NO is parallel to MP, and we know that these angles are we know that this can be the transversal, and we know that angle N is congruent to angle P. So the second statement would be that angle NOM is congruent to angle PMO because of alternate interior angles theorem. Since these lines are parallel, then these alternate interior angles are congruent. Next, we can say that MO is congruent to MO. And that's reflexive property of congruence. So now we have an angle, and a side. So angle N, NOM, and a side. So we're going to say that these triangles are congruent by angle, side. Now that we know that the angles are congruent, we can say that angle NMO, this angle right here, is congruent to angle POM by CPCTC. Since we know the triangles are congruent, the corresponding parts are also congruent. See how M is the vertex and M is the first letter here? O is the vertex of this angle and O is the first letter of this triangle. These are corresponding parts. Lastly, since we know that these angles are congruent, and now we can kind of, so this angle, why don't I draw it out for you? Oops, wrong pen. Since we know that this angle and this angle are congruent, and these are alternate interior angles to these two lines, we can use the converse of alternate interior angles theorem to say that MN is parallel to OP. So it's just putting it all together. And then we have one last proof that we're going to take a look at. And it's using CPCTC on the coordinate plane. So we're given points of two different triangles, D, E, and F, as well as G, H, and I. And we need to prove that angle DEF is congruent to angle GHI. Now, there are a lot of things that we can do on a coordinate grid, but it's really hard to tell the angles it's really hard to tell the measure of angles on the coordinate grid. So we can't simply just measure it. We need to prove that these triangles are congruent, that triangle DEF is congruent to triangle GHI. And once we prove that the triangles are congruent, then we can say that these angles are congruent. So to prove that these triangles are congruent, we're going to plot the points, GH and I, as well as D, E, and F. So once we've done that, we can then prove that these triangles are congruent by side, side, side. Yes, we can prove by transformations, but we can also prove using side, side, side. And so to figure out the distances of all of these side lengths, we can use the distance formula, which remember is D distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we will need this for the rest of the unit. The distance formula is going to be really important for the rest of the unit. So let's start off with DE. So x2 is -3 minus x1, -5. So -3 minus -5 would be, this turns out to be -3 plus 5, which ends up being 2, and 2 squared. So this would be 2 squared, or 4. And DE ends up being -1 minus -5, which ends up being, so that's 1 plus 5, which is 4, and 4 squared is 16. So then we end up with the square root of 4 plus 16, which equals the square root of 20, which we can then rationalize the radical, and this will be like 4 times 5, and we get 2 radical 5. We can do the same process for all 6 sides. So for EF, GI, and GH, and HI. So now that we have the side lengths for all 6 sides, we can now see if we can find some congruent pairs. Well, DE and GH are congruent to each other. They're both 2 radical 5 distance apart, or in length. EF and HI are congruent to each other. They're both radical 5. And DF and GI are congruent to each other because they're both radical 13. So we have 3 pair of congruent sides. meaning that we can use, since we have these three pairs of congruent sides, we can say that the triangles are congruent by side, side, side. So the triangles are congruent by side, side, side. And therefore, since these triangles are congruent, we can say that angle DEF is congruent to angle GHI by corresponding parts of congruent triangles are congruent. And with that, we are done. And basically, this unit was getting more used to, one, doing congruent triangles, proving congruent triangles, and two, getting used to the coordinate grid, because the next 3 units are going to be very heavy in the coordinate grid. All right. Good luck on your unit, your 5.5 online quiz. Please attempt it. That's what I ask. If you don't pass it, try at least one more time. And then if we still don't get it, that's A-okay. We'll come to class and we'll get it going. All right. Have a good night. Bye-bye.